Hello, I'm Nobby Clark, welcome to my workshop. My project today, or over the next few days actually, is to make an adjustable parallel. I did make one of these a few years ago, which is this one here. When I made this, I didn't appreciate how the two parts slid together. When I investigated a bit further over the last couple of days on the commercially available ones, I obviously then realised that the two parts run in dovetail joints. When I made this one, I made it out of aluminium, and I just cut a piece of aluminium across, then machined the angles to be accurate to one another, and then machined a slot through both pieces, and used another piece of aluminium here to join the two halves together, and these are locked together with small set screws or grub screws. The problem in using the set screws is that they do actually dent the material here in the middle, and that then sort of causes the two parts to grind a bit or jam together, so I've had to sort of rub that part down. Although it's not made in the correct way, I have used this quite a number of times. I've not actually used it as a parallel in the milling machine vise, but I've used it a number of times to help me position bits of material for various machining processes, using it like you would do a machine jack, just by sliding it up under a piece of material, then locking it to support the piece of material I'm working on. Now, I'm not going to be able to make one using a dovetail in here. Well, obviously I don't have a dovetail cutter that small. I guess they probably are available. I've not checked that, but I guess some people that have made these themselves, that have used dovetail cutters, have probably made the dovetail cutter themselves, but I think to do that you would need the machinist cutter grinder to do that, something I don't have and never will. So I'm going to make it in a similar way to this, but I hope I've devised a means of locking the two parts into position in a slightly different way this time. And the object here is going to be to use it as a parallel in the milling vise as well. So I want to try and make this as accurate as I possibly can. Obviously it's very important that once you've made this, that it is completely parallel. I'm going to make it this time out of steel. I've got a piece of steel here. This is 3/4 inch by 1/4 inch, and I'm going to make it 2.5 inches long. So the first stage will be just facing it to length. It hasn't got to be absolutely precise, but once I've done that, then I can mark the angle across, cut the two pieces in half, and then machine the angles. Now, the angle on here compared to the commercially made ones I know is completely wrong. I've looked at lots of pictures of commercially made ones, and as near as I can work it out, the angle seems to be about 7 degrees, or 7.5 degrees. I can get that to 7 degrees by using two angle setup blocks out of my nice set here. So I can use these two together to give me the angle I require. Now the amount of adjustment that I need hasn't got to be too great. It's just to make sort of quite small adjustments. Although even at that angle, hopefully this one would be capable of achieving greater depths. But for me, there's no point, because the depth of my milling vise isn't very great anyway. So there's really no point in making it too big. One reason that I wouldn't really want to buy a set of adjustable parallels. I mean, for one, they are quite expensive to buy a complete set of them. Even the import ones are quite an expensive item. You can buy some of them individually. I've seen adverts for individual ones. Even so, they're still quite an expensive thing to buy, and I think that it's going to be fun to try and make one actually, rather than buy one. So join me on the adventure of actually making it. So the first thing I'll show you is just sort of bringing this to length, and then I'll show you the angle I've set up. I probably won't show the bit of me sawing these two bits apart. That's going to take me quite a long time to do, and I'm going to have to do it by hand. There's no way that I could set this up in my bandsaw to do it. So that bit I'll definitely do off camera, but obviously I will bring you back for machining the angles. I'm having to make this video over a few days, because when I check through all the end mills I've got, the end mill I require for this project I don't have. I did have one, but when I examined it closely, it's obviously unusable. It's blunt now, so it's obviously quite an old one. So I've had to order a cutter, which I'm hoping will arrive in 2 or 3 days, so that I can complete this project to show you. But anyway, sort of join me for the adventure on this, and we'll see how we get on. The first stage, as always, with any project, is bringing the material, in this case just to length. The material I'm using is cold rolled steel, which is 3/4 by 1/4, and I'm going to machine it to 2.5 inches long. I've already faced off one end, and then now just face off the other end. Parallels in the vise, and I'm using one of my springs here, which I've shown before. One of these springs made out of sprung steel to hold the parallels apart. So pop that in there, and we'll lock this piece in the vise. Just tap it down, make sure the vise is nice and tight, and then we can bring the cutter down to machine this to length. Cutter it at a suitable depth here, put that in position, and we'll wind that in. I'll just pause the camera for a moment and bring you back when I'm sort of nearer to length. Well, hopefully this will be my last pass. Um, that's I think about as near as I can get it. Couple, about 1.5 thou under, but that's fine. It hasn't really got to be that precise anyway, so that's for me is fine. So now just got to remove this and just deburr it, and then get on to the next stage. And here you see I've blued up the part, and I've scribed a line across here. That'll be my cut line, so I've got to cut the two pieces apart along that line, ready to machine the two angles. As I said, I've got to cut this by hand, but I don't think there's any way that I could get this into the bandsaw. Unfortunately, that if I could, that would make it such an easy job to cut these two bits in half. But the distance between the vise and the cutting blade on the bandsaw is just really too wide on this particular machine. But there we are. And I do have a vertical bandsaw, but it's basically for cutting wood, so I think actually it probably runs a bit too fast to be able to cut this piece of metal apart, but never mind. Anyway, I'll see how I get on with it. I'm going to do this off camera because this is obviously going to take me quite a long time to do, and I probably need to have a holiday in between cutting it as well. Anyway, bring you back later. Well, I think I may have come up with a way of possibly cutting this using my bandsaw. What I've done is I've clamped the piece of material you can see here, the bit of material, to this piece of steel, and I've used a couple of very small clamps to clamp it onto that bit of steel, and then lock that into the bandsaw vise. See, the problem with this machine is that there's quite a big distance between the edge of the vise and the blade itself, so it's only really possible normally with this machine to cut bits of material off at a fairly long bar. It is one of the problems. I've thought of possible ways of getting mounting another sort of vice onto it, but there are various other sort of projections here on the bandsaw that would really get in the way. When I've cut bits of material in this way a number of times before, it's really a matter of trying to be creative with it. Whether this will work, I just don't know. It may scrap the part. We'll just have to see how we get on, but it's worth trying this out. I'm hoping the material is, I've tried to clamp it in as tightly as I possibly can into position, so if I go very gently with it, it may work. I'm not going to be able to film this part of it. For two reasons: it's going to be sort of a difficult job, and if it doesn't work, you're going to hear me scream at the end. But let's see how we get on with it. Well, I'm happy to report that worked. It's cut through very nicely, actually, and I've managed to keep to my my scribe line. So I'm very happy with that, because that would have taken me quite a long time to have cut through that, and the chances of me being able to cut through that with a hacksaw and get the cut as straight as the bandsaw has done was I think almost impossible. So I'm very pleased, and this was all done without any adult language at all. So let's proceed on with the next job now. Machine these two angles on the milling machine. That's the next thing to do. Okay, my next job is I've cut the two pieces in half here, is to machine these angles accurately now to 7 degrees on both parts. I'll start with the smaller part first. Now, obviously using my angle setup blocks, I've got a 4 degree and 3 degree together. But to give me sufficient height here inside the mill vise, I haven't got any parallels small enough. The smallest one I've got would raise these up too high to be able to grip this piece in place. So I'm using a 1/4 inch blank high-speed steel tool bit, so that can go in first, and then the angle setup blocks on top. I'll need to bring this one just back a bit so that I can get the material actually sort of gripped in the vise. It's always a difficult thing to get these. I've found to get everything in position basically. So I've put my vice stop on the end, and then I can, only temporarily obviously, which gives me a means of holding that all in position very firmly. And I'm going to use a piece of because all of these parts basically are the same width. They're all about a sort of a 1/4 inch wide, so I'm not going to be able to grip this with the moving jaw. So I'm going to use a bit of aluminium wire against the part here to hold that in place. So I very carefully bring that in, and hopefully that will hold everything in position. Make sure I've got everything down firmly, but using the vice stop, I can sort of push everything down really firmly in place, and then lock the piece of metal in place, lock that very tightly in place. Now I can remove my angle setup blocks and remove the vice stop as well. Take that off. So now I've got the piece of material blocked in place. Make sure I've got that done really tight. Now hopefully I can machine that now without anything moving. I'll just move that. Well, it really doesn't matter so much about that, but I can move that out. So I'm now ready to machine this part down. So I'll get the cutter down and in position and do that. There's no sort of specification for this at all. Basically, all I need to do is to machine this to clean it up. There's a fair bit to come off because my angle wasn't sort of that accurate, so there's a fair bit to sort of to come off here, but at least it's, you know, going to bring it to the right angle. Okay, well, I'm all set up to just basically clean this up across here. There's no spec, as I mentioned, for this. It's just purely a clean up so that I get both bits to exactly the right angle. When I'd just shown setting this up, I looked sort of along here, and really at 7 degrees it was going to taper this down, I think, a bit too much at this end. So what I've done is I've actually changed the angle from 7 degrees to 6 degrees, and I mean, it's still going to work, I think, but looking sort of along here and taking a measurement here and here, at the moment it's roughly the same, so hopefully it will be a fairly straightforward clean up cut along here. But let's see how we get on. I'm just hoping this is going to hold firmly in the vise while I do this, but once I start we'll find out, won't we? Anyway, let's have a go and see how we get on. Just going to have to keep moving this backwards and forwards and changing the cut depth until I get a bite on it, basically. Not quite there yet. That's it. Right, well, I have managed to get a cut all the way along there, so I'm going to leave it at that. You know, I don't want to take this down too much because I don't want to thin this end down too far, so I think that will be okay, and I'll get set up to do the same to the other part. And I've got the next part set up in exactly the same way, but I've set this a little bit higher in the vise because once I've machined this off here, I've got another procedure to carry out on this part. So I want this to be mounted in a slightly higher up, but this is the wider part anyway. Okay, well that's cleaned up right the way across, so that's hopefully going to be okay. So I just need to do a bit of a clean up, but what I will need to do is very carefully deburr this all the way around without removing it from the vise. Now this is in position. The next procedure is to machine each side of this piece of material to give me a tongue in the centre, because the two parts, it will actually be a tongue and groove fitting. So what I want to end up with is the centre part of the tongue here to be 1/8 of an inch across. That's 0.125. So what I've done, I took an accurate measurement of the thickness of the material, and then deducted the 1/8 and then halved that amount to give me the depth I need to go in here. The depth of cut in this direction is also going to be an 1/8 of an inch. So what I did first was touched off on the top here, and then brought the cutter down to 0.125 and set that on the DRO. So what I need to do now is to touch off on this side and bring the cut across 0.062 across here. So what I've done to do that, I've just used a piece of cigarette paper between the part and the cutter, and then move the work, the cutter across until I touch the work, and then sort of jam the bit of paper in position. So we're in position there now. So I can run the, make sure I've got that. Let's do that again. That's it, so that's locked quite nicely. Now I can bring that across. That will drop the piece of paper out. I can bring that back and move the cutter across to make sure I'm actually touching the work, which I am. So I can zero the wire movement now and put a cut on. I'm going to do it in a few cuts basically, to sort of gently machine that part out. So let's bring that across, make a cut of about 0.03 initially. That'll do it, that'll be about right. Yeah, a bit of cutting one across there, and let's make a cut across there now. Okay, so that's my first cut. So now I can make it, or probably a second, and then a third cut across this part. What I'll do is I'll bring you back when I'm ready to make the final pass across here. Right, ready to make the final pass here now. Okay, that's it, I hope. We take a, actually move that up out the way now. We'll take a measurement. Right. Well, I reckon on just a fraction of about 2/1000 over. So when I cut the groove in this with a 1/8 end mill, I mean, if the end mill happens to cut a fraction oversized, hopefully I'll get a good fit. So that then these two parts will slide together. I'm going to make a measurement just to make sure I've got the depth right on both sides. Looking at, from the end here, it does look okay, but I'll try and find my depth gauge and take a measurement along those sides. So hopefully I've got it there. I can't cut the groove yet because I'm actually waiting for my 1/8 inch end mill to arrive, because the one I've got is completely blunt and I only had one of them. So once that arrives, I can carry on almost the final stage. There's one other part to make, which will be the lock that will lock these two parts together. But obviously I'll show that as well. The next job is to cut the 1/8 of an inch groove through the centre of this piece. I received my 1/8 inch end mill this morning, which I hope is going to do the job well. I bought this on eBay from a seller up in the Midlands, and it's a British made one. The brand is Osborne, so I'm hoping this is going to be a good quality one and much better than the ones I've had before, which were import ones. So we'll see how we get on with this. To set that, but obviously I need to find the centre of this piece. So I'm going to use my edge finder to do this. And once I've found the centre of the piece, I'm going to lock the Y movement very, very firmly, which hopefully will set the position of the back jaw, the fixed jaw, so that when I set this up, using a piece of aluminium bar to hold it in place, as I've shown before, that the fixed jaw will be my registration, so everything set against that will keep that centre position. So the procedure is as always the same. Find the first edge, and zero the Y movement. I'm going to double check that. And that's fine. So I can bring that down to the other side. do that again. Okay, zero that. Set the half function. Lose that up and bring that back across to 0. So that should put me exactly over the centre. So now I can lock the wire movement, lock that firmly in place, and now I can remove the edge finder and set up now to, ready to machine the slot. I've clamped the workpiece in the vise and set it up exactly as I showed before. I used a 1/4 inch piece of tool steel just to give me a little bit of extra height in here, and used the 2° and 4° angle setup blocks to give me the 6° angle. What I've also done is just a bit of an experiment, is to set up a clock gauge on the surface here and run that across. It's within I reckon about 1.5 thou, which I think for my purpose is going to be fine actually, because when I'm cutting the slot in here, actually I think slightly better now. It's a thou, around about a thou across, because I can cut the slot sort of basically deep enough so that the contact is made on the top surface, not the slot, and the surface here. That's obviously the most two important surfaces involved in this. So I'm sort of quite happy with it. I don't think I'm going to worry any further. I've locked the part in the vise very, very firmly, and as I mentioned, I've locked the y-axis so that hopefully I'll keep this registration, so I can set up now with the end mill and start the process of cutting the slot out now. I'm set up with the cutter now. I'm not going to film all of this, obviously, just perhaps a couple of passes, because I'm going to take these very, very gently and make quite small cuts, I think, in each case, until I bring it to depth. I've only got one cutter here. I did order 2 of them, but I got a message back from the seller that when he posted off, he realised he'd only put 1 in the bag. So there's another one following, which probably won't be for a couple of days. So this literally is the only one I've got. So if I break this, there's going to be another delay. But anyway, let's see how we get on with this. I hope you've got a reasonable view of this. But anyway, let's see how we get on. Okay, well, I'll bring you back when I'm sort of nearer to the end of this. I think the trick also is going to be use lots and lots of cutting oil on this as well to try and preserve the quality of the cutter. Well, this I think is going to be the last, my last pass over the bit apart. And it doesn't matter if the slot is a fraction deeper than perhaps it really needs to be, as long as the two parts meet on the shoulder of the part. Okay, got to clean out. That's got to go in that way, I think. I'll get my hand around the back here, so that should enter into the slot, and the sort of shoulder here meeting the top of this part is what I want. So it seems to be okay. Hopefully I'll have a look at the cutter and hope it survived all right. I'm glad it didn't break. That's the main thing, because that would have stopped the whole operation. But there we go. Anyway, let's take the put the thing out. Ooh. I did put it in tight. So there we are, that's the slot, and it should, I've got some bits of swarf in there, but so the two parts will meet. The depth has come down, well, it's broken into the bottom here, but I just need to do a bit of a clean up on that. So hopefully that's going to be okay. Yeah, but I've got some swarf inside that to clean out. So there we are. Job not finished yet. I've still got the lock to make for it, so there's still a little bit more to do on it. But I should bring you back for that part as well. Well, the slot's cut. Somehow I didn't manage to get it perfectly in the centre. Even setting it up with the electronic optical edge finder, I'm slightly out with the slot, but oh well, what can you do? But I have got a reasonable fit, and I've managed to machine it so that the shoulder here and the shoulder here meet quite happily, and the two bits will slide okay. It's very, very close to the edge at the bottom here. Obviously it's not going to be pushed down that way, but obviously that the tongue part will go through the little slot there, so I've just filed that down to make that level, but the adjustment's really going to be made that way, not that way. So what I've got to do now is put a little locking screw in to lock the positions of this. What I'm going to do, I've actually made the screw, so quite a simple exercise. I've made a screw out of brass. I've tapped it with a 1/8 with thread, which I discovered is exactly the same as an ME size as well. I didn't realise that the thread form was exactly the same on those, because the die is ME but the tap is 1/8 Whitworth. Anyway, and I've cut a little slot in here as well. So what I want to do is that the locking screw will be mounted on this side, is to, you see I've blued this part up, is to mark on here the depth of the slot. Get this to stay together, depth of the slot here, and then drill and tap a hole as close to this edge as I can, so that when I tap the thread, what I'll need to do is to counter bore through sort of through this part, so that the head of the screw will go below the surface, or a little bit below the surface, and then the edge of the head of the screw will lock against that to lock it in position. That's the aim. See whether I can actually achieve that. So that the next thing will be finding the right position here for the screw, and drilling, counter boring and tapping to take this little screw. My nice 1/8 inch Osborne 4 flute mill, end mill, worked really well. Obviously far superior quality to the import ones. It is a Clarkson threaded type, but that makes no difference. Obviously I'm locking on the shank here, but I did examine the end of the mill, and there's not a mark on it, so it's going to be perfect, ready for the next time basically. So there we are. So that will be the next stage, to drill that, as I say, to drill the hole out for my little brass locking screw, and that will bring the project to an end. So I'll probably bring you back for perhaps a little bit of this. That the screw is actually too long, so once I've got it all set up, then I can file the screw down so that it runs flush with the opposite side here, or the opposite side of this piece actually. So there we are. So I'll bring you back for the next part of this. I've decided to do the drilling and tapping on the milling machine, because I think that's the safest way of doing it, rather than the temptation of doing it on a bench drill, so that I can get everything as accurate as possible. So what I've done, I've set the part up on my finger plate here, which has got its own clamp on it, so I can clamp the part over this V cutout, so I've got clearance for the drill, and that is mounted over the T-slot in the mill bed. And the plate, you can see I've clamped that down with a couple of toe clamps on each side here to hold it in position. I've locked those down very firmly in place, and I'm using my centre pointer here to align the punch mark that I've made, which I hope is going to be in the right position for the 1/8 inch thread, as well as the threaded part, which will be on the sort of back side of this part. So the thread will be down here, and on the top I'm going to have a counter bore to take the little brass screw. I've already made a test. I mean, I've not got counter bore drills anyway, so I'm going to have to use a regular drill. So I had already measured the head of the screw, which is 3/8, and a 3/8 drill will actually give me a good counterbore size. I've just used a bit of scrap aluminium here, and I've drilled into this like a sort of a counterbore, and the little screw goes in it okay, so that should be absolutely fine. Of course, this will all be done in the one setup to get everything completely parallel, so that's hopefully it's going to work okay. I'm going to do this operation off camera because it's a bit cramped here really, and having the camera right next to me, I think I need to sort of getting fairly close to do this, and there's not going to be room for you as well. So I'll show you the part sort of once I've finished it. So I'm sorry I'm not going to do all this on camera, because I'm sure you can understand this. I've not got a lot of room here to work, so let me bring you back when I've actually done this operation. Well, it seems to have worked okay. I just tapped the thread. I did attempt to use my teeny Eclipse style tap holder to do this, but it kept hitting against this part. You see here, so I've had to use one of my tiny Eclipse T-wrenches to get through that. So hopefully everything's going to be okay, but until I get the little screw in there, I won't really know. But anyway, let's get the tap out. There we are, and we'll release the toe clamp there. I just have to sort of blow that hole out and do a little bit of deburring around. Let me just blow some air through that and see if we can see whether that's okay or not. I don't know how well, I'm trying to look at the camera as well, how well you can see that. So I've as I say, drilled through for the 1/8 inch tap. It's a 2.5mm drill. After I drilled the hole through, then I used the little drill here to do the counter bore. I've tried the little screw in it, and that goes in fine. And I don't know whether you can see inside there, it's the counter bore is just broken through in the edge of the slot there, so hopefully there's enough there to enable the underside of the head of the screw to lock on to the other half of this. But I'll give this a good clean up, and then we'll test it out and see if it's okay. Bear with me. Well, I managed to finish the part, and it's come out reasonably well, I think. The little brass screw that I made, I've managed to get it just below the surface, and I've filed the little screw off in length so that it's just below the surface here as well. So if this was perhaps used in the milling vise, then these aren't going to get in the way of the jaws closing. So by just releasing that, I also made that cut a little bit deeper. I actually did this with a junior hacksaw. Seemed to be the easiest and neatest way of doing it. I suppose it could have been done with a slitting saw, but it seems to have worked out quite nicely just doing it with a saw blade. So if I release that, the two parts will slide quite happily, and then if I lock the two parts together, obviously you've got to be very gentle with brass screws because they from experience, I know that they can burr very easily, but the parts now will lock nicely together. Obviously there's lots of other uses for adjustable parallels. I think, I know from what I've seen on YouTube channels, they don't seem to be used as much in the way that normal parallels are used. Often they can be used if you've got something mounted in the milling machine and you want to support one end of it, that these could be brought up under a piece of material to support it one end, like a screw jack. And also I guess one very good use for them is to measure gaps in material, slots, so they could be adjusted into a slot. Maybe sort of a slot they could be adjusted into it. Don't necessarily need to lock them, just push them together, and then you could measure across the end with a caliper or a micrometer to measure an accurate measurement in a slot. I have measured these up with my digital caliper, and there is a discrepancy from end to end of about 2.5 thou. I'm not surprised. It'd be a miracle if I could get these absolutely the same from end to end, but obviously what I could do is clamp this up very, very tightly, and as these are below the surface, I could mount that in the milling vise, mill vise, and then machine across the top and see if I can get the measurement even better. But we just have to see whether I decide to do that or not. But it's an interesting project, really, to make something like this. I suppose sort of thinking about it, I suppose having a set of these, I guess, has the uses, because perhaps I'm not thinking about it in the right way, that they've got so many different types of use. But using them, my thought was sort of using them in the milling machine vise. I didn't need it to be very big, because my milling vise isn't very deep, and I've actually put this in the milling vise, and this could be put on the top of another parallel to make a sort of very accurate sort of height adjustment. But anyway, I'm just going to turn the camera so I can actually face you, because I've just got something else to show you before I wind up this little video. Just before I wind the video up, I've received another couple of workshop stickers. These are both from channels which are relatively new to me, and we've done an exchange of workshop stickers as well. The first one is the English Hobby Machinist. I mean, both of these channels I would highly recommend that you have a look at them, and if you like them, obviously subscribe to them and look back through the back catalogue as well. The English Hobby Machinist, again, I think he's possibly a retired gentleman, I don't know. He works from his garage, and I found his video basically because he makes quite a lot of model engines, which is something that I'm very interested in. So I try to find channels that show the making of models. He actually makes quite a lot of models just from plans, not from kits or kits of castings, where there would normally be a casting. He's actually making the whole thing. So they're very, very interesting to watch if you go back through a lot of his videos. He's making a modular engine at the moment. But the interesting thing also on his particular channel is that in between the videos on the model making, he makes all sorts of other little projects, I guess, like I try to do sometimes, a sort of a one-day project making various tools and accessories for his workshop as well. So when we give him a look, I'll put links to both of these channels in the description below for you. The other one is Julia's Shed. Julia's channel's also absolutely brilliant. Julia is pretty obviously a very experienced machinist. You see the quality of the work that she does. She has an older, slightly older than mine, an old Myford lathe, but she's very expert in handling all the lathe procedures. She also does plasma cutting, welding, everything like that, which is wonderful to watch. But Julia is very much into the slightly larger scale of model railway engines, and she's building a railway engine at the moment, and recently bought I think an engine which was already completed, and she's been taking it apart and cleaning it up and making all sorts of adjustments to it. But in between a lot of these videos, she takes you along to various club circuits where all the members there run their engines around the circuit. Some of these big garden circuits are absolutely beautiful. The track layouts are absolutely fabulous, wonderful scenery as well, and I find them very peaceful and calming to watch as well. I quite like watching these engines go around, although I don't know that where I live in Buckinghamshire that there are any model railway clubs here, not really that I know of. The only time I really get a chance to see anything like this is usually at one of the model engineering exhibitions, although the last one I went to, which was the Midlands one, they didn't actually have many railway layouts there, which was a bit disappointing, but there we are. Anyway, give Julia's channel a look. I'm sure you'll like it, and I'm sure you'll subscribe to hers and to the English Hobby Machinist as well. I'm going to put these up on the board now. I'm not going to show you me doing this because I have a lot of trouble peeling the backs off these, but I will show them on the board and explain about the new board I've got and its new position in the workshop. So bear with me just for a few moments longer. Well, there we are. This is me, and this is my new sticker board. I was originally putting these on one of the doors of one of my workshop cabinets, but I suddenly realised that once that door was filled up and I used the others, the sticker boards would be getting lower and lower and lower. So I've rigged up this much bigger board, and it's on the panel of the workshop just to the side of my desk in the workshop. So here we are, Julia, you're up here next to Myford Boy. And English Hobby Machinist Mark, you're here. So it's gradually filling a little bit. I've also made contact recently with another channel in the USA, and we're exchanging stickers. So there'll probably at some point be another sticker coming across from America very soon. So that will add another one to the board. So there we are. So that's me and the project for today. I'm sorry the video is rather long again, but there was quite a bit of work involved and quite a bit of machining in this, which I hope you'll have enjoyed anyway. So anyway, thanks again, thanks for joining me, and again thanks to all the subscribers to the channel, and hopefully I'll have another interesting video for you very soon. So cheers for now, bye bye.